Okay, good afternoon and welcome this Nordic Ventilation Forum online webinar. Today we work this webinar together with Nordic authorities, which you can see here, and the host of this seminar is a Scanvac organization here. Today in the program, I would remind you that all these presentations and this video will be published later in this week in the Scanvac webpage. Another thing which is quite important to know that you are not able to ask questions and for use a microphone, all the questions I propose you do it when you listen to talks and make comments in the question and answers to chat. And after this presentation, we'll come back for your comments and questions. And today we have very nice and interesting program here where we talk about many different aspects of this ventilation here. And we have several talks which are here mentioned. But first I will introduce all the speakers here. And the opening will, after a couple of minutes, Hans-Olof Carlsson Gjörd. He will talk about opening words of this webinar. He has had long history of this indoor air quality area for different aspects, sick building, thermal comfort, energy, and so on. And the next speaker is Siru Löfqvist from Finland, and he has been executive manager of VVS Förening in Finland for 20 years. He will give a talk about result of the cooperation. And the following speaker, Kim Bitchen, he will talk about updating the weather data for design, and he's working as a senior scientist at the Danish Building Research Institute and Aalborg University since 1992. And then we have Peter Brander. He will talk about tracing air quality in ventilation system by using OVK boosted with IoT technologies. And he has been specialist in ventilation thermal comfort at Boverket, National Board of Housing, Building and Planning in Sweden. And after those, we will have short break, and then we continue this webinar. Johannes Olof Ristesen will talk about Danish changes to building regulation with regard to ventilation. And he is working as an engineer in the Danish Housing and Planning Authority, and is specialized for technical installation and indoor climate. And then we have Niels Bruce Warning. He will talk about Danish changes to building regulation with regard to ventilation, and he has working many years with energy efficient and sustainable buildings in the Danish circumstances. And then we have Juhani Hyvärinen, who will talk about indoor air quality requires wide collaboration across the sector, and Juhani has worked over 30 years in various tasks of industry and research centers and working with the HVAC system for wide scope. And at the moment, he's working at Finnish Building Services and Trade Association in Finland. And program continued, and we have Lars Ekberg. We talk about reducing risk of spreading pathogens in indoor environments. Lars have worked at CIT, energy management, and also at the Chalmers University in Sweden. And after those talks, we have time for have discussion and answer for your questions, and all the speakers are available for questions and answers. So for the next, I will ask Hans-Olof to give the greetings and open this webinar officially. So Hans-Olof, floor is yours.
Thank you. I'd like to welcome you all very much to this millennium first Nordic Ventilation Corporation meeting. A little history. In 1995, I started at the National Board of Housing, Building and Planning in Sweden, and that was at the last breath of NKB, the Nordic or the Nordic Committee of Building Regulations, and that has been a little asleep since then, though we have had a lot of cooperations. In 2011, our Swedish bostadsminister, housing minister, Stefan Attefall, tried to get an ongoing work on harmonization of building regulations. And it hasn't gone so well because we choose subjects that was so far away from each other that the different countries' building tradition didn't allow us to get close enough. But some years ago, we started with having talks about new areas such as climate, and we started 2018 a climate forum for the Nordic countries with industry, academy and authorities involved. And after an idea from zero, we started up this ventilation project, and our aim is to describe the different countries' regulations so that we can see that it is quite similar. So with these words, I would like to say welcome to all of you, and let Zero start talking. Thank you.
Okay, I was waiting for Rita to say some words, but I will take over now. Good afternoon, all. I have the pleasure to give a short overview of the Nordic collaboration within ventilation the last year, or focusing on the last year. Now, then let's start to discuss a little bit what kind of networks we do have. We have several kind of different Nordic cooperation networks. We have this network of authorities in charge of ventilation regulations. They started to have regular meetings a year ago. Then we have the Nordic Ventilation Group, that is Nordic academics sharing the same interest and concern regarding the indoor climate and ventilation. They have also started to have regular meetings already over a year ago. And SCANVAC, that's mentioned here, is the Scandinavian Federation of Heating, Ventilation and Sanitary Engineering Associations in Denmark, Finland, Iceland, Norway and Sweden. And also the industry, the HVAC industry, have cooperation, and that cooperation has been intensified. So why do we cooperate here in Nordic countries? Well, we have similar culture, similar climate that we are dealing with, and also our building constructions are alike. So it's quite natural to have interest to cooperate with each other. Just to highlight some results of the cooperation, I start with the authorities. The first thing was to prepare a list of different bodies or organizations that issue regulations and guidelines for ventilation. There is a lot of different regulations and guidelines. Some of them are binding and some are issued by private actors, but all these steer ventilation design. And the authorities collected information about all these and prepared a list, and that list is published on the Scanvac webpage, and that's available for all. We made some observations. The structure of regulations and guidelines is a bit different between countries. Several national authorities give regulations for same parameters, which is quite interesting. The use of standards and references to them difference between countries. For example, in Finland, we don't refer to standards in our regulations in ventilation design. And the parameters which are regulated are not the same between countries. And there is also a large variation between countries regarding which parameters are regulated as mandatory and which are on a guideline level. And it seems like Sweden and Finland is quite on the opposite ends of the scale. In Sweden, hardly any descriptive regulation, and in Finland, some very detailed mandatory requirements. Also, there has been discussion on many interesting topics, and I raise here some of the topics that has been discussed and that is of common interest. One is the kitchen ventilation. In other words, how to supply enough replacement air during enhancement of exhaust air. There is new regulations under preparation in Denmark, and also the authorities in Iceland are looking over the regulations. In Norway, they have had some investigation. The building authority has performed an investigation of fumes in homes, and there is information from all Nordic countries. And in Sweden, there was a competition arranged by BEBO, that's a Swedish energy agency network for residential property owners committed to energy efficiency. And the winning systems, or some of them, I think they are starting to test them, so how they will work. And there is a lot of information about that, but in Swedish on BEBO website. Another interesting topic that has been discussed is overheating and climate change. There is updating of weather data for design ongoing in several countries, and Kim Witchen from Denmark will talk more about this after my presentation. But there is also overheating problems in current buildings in more or less normal weather conditions. And when we come to net zero energy buildings, you can't allow almost any sunlight in without overheating. So there is a discussion, maybe we need to have cooling also in residential buildings in the future here in the north. And the other question here is that homes has become places where people work. So we are also faced with the productivity issues. It's not just a home anymore. One topic is the criteria of ventilation. How shall we define good indoor air quality or indoor environment quality? And there has been some discussion, could tail index be a solution for this? That includes the thermal environment, acoustic, indoor air quality, and also lighting. And also discussion, should we design ventilation in another way today? And we should also verify the indoor air quality, which means more measurements. But what shall we measure? Some more observations. Even though there are some differences, the regulations in Nordic countries are overall quite similar, especially in Norway, Sweden and Finland. Denmark maybe differs a bit, maybe due to the climate or influence from Central Europe. In Nordic countries, the focus is in regulations on high efficiency, SFP, coefficients of performance, life cycle cost and pressure drop. So the problem don't seem to be that the regulations are so different in the Nordic countries, but it seems that it's difficult to find information about all the regulations in the country. Then we go a little bit to the cooperation between the academics. There was a Nordic ventilation group that was very active in 80s and 90s when mechanical ventilation became more common in Nordic countries. But due to some of the countries joining EU, the cooperation wasn't that active for several years. But now it's all again activated in spring last year. And this group of academics, Nordic Ventilation or NVG, they have several task forces. They have had many meetings, shared information about projects, outcomes, newest information, and also very tight collaboration with the RIVA task forces, RIVA being the European Federation for HVAC Associations. The academics have been quite active. They have published some criteria for room air cleaners for a particular matter. That criteria was published on Scanvac webpage. It was also reviewed by RIVA TRC, the Technology and Research Committee, and also by RIVA COVID Guidance Group. And this was also published on RIVA COVID Guidance page and as an article in RIVA Journal with the title Effect of Portable Air Cleaners on Indoor Air Quality, Particle Removal from Indoor Air. I've included in my presentations all the links, so if you are interested to read more, it's easier for you to find them. But short, if you plan to get an air cleaner, in these criteria is written some parameters that should be considered. There is described a clean air delivery rate, something about noise that should be taken into account, energy efficiency, placement of the air cleaner, service and maintenance, also the generation of pollutants and operation and service. Then there was a summary on effects of indoor air humidity that was edited by Olli Seppänen with significant contribution from other members from NVG and illustrations by Lars Ekberg. And that summary is published on Scanvac webpage and also as an article in RIVA Journal issue 2. This was also reviewed by the RIVA TRC and the COVID Guidance Group. Oh, sorry. Oh my God. pressed the wrong button and then I closed the presentation. Well, at least you noticed that this is live. Things like that can happen. And that summary has a lot of information. It has information about the conception of indoor air humidity, humidity and health, how humidity affects health, the difference between absolute and relative humidity, also droplets, microbial growth, humidification, energy use, and a lot of other things as well. Then the academics has also been discussing ventilation criteria, and the evaluation of ventilation criteria has started. They think that the criteria should include control of respiratory infections in the future. And to think about how something should be changed, it's important to know the history and current situation. And there is a very nice article written by Pavel Vargotsky that's published in Riva Journal with the title "What We Know and Should Know About Ventilation." And Lars will talk more about this issue later on today. I mentioned Riva Journal a lot of times already, and the reason is that this group wrote a lot of articles in the issue 2 this year. That was an issue that was focused on cold climate, HVAC, and energy issues, and a lot of articles from the Nordic countries. And I want to point out that Estonia is very much involved also in this NVG group and very active there. And they also plan to make a Nordic issue next year, but it was quite a success. And a lot of other future plans ongoing in the NVG group. There is an article on effect of gas phase air cleaning on indoor air quality that's almost ready and will be published soon. There will be a summary article on testing air cleaners. Later this year, there will be published general design and operation principles of ventilation systems of indoor air quality on Scanvac webpage. That is based on a Health Vent project. Then we have criteria for air cleaners with combined filters, a criteria for induct air cleaning devices, and maybe a guide to air cleaners in residential buildings. The group is also very actively involved in the renewal of the EN standard 16798 and the parts 1, 2, 3, 4, and plan or are writing about ventilation efficiency that could be an appendix to the standard. Also, the principles of targeted ventilation are developed, and that could be then used both for EN standards and also in the Riva guidebooks work, that there is a lot of cooperation ongoing. And then Scanvac, as I mentioned to you, it's an association of or a federation of the HVAC associations in Scandinavia. And through Scanvac members, we are able to share info to all the personal members in national language through magazines, websites, courses, social media, and so on. And of course, the focus is in issues that are interesting for the Nordic climate and Nordic countries. Scanvac has also 2 conferences, Room Vent and Cold Climate. and there is also very much of knowledge sharing ongoing. Here are the logos of Scanvac member associations, but I included here also ECVI, that actually is not a full-blown member of Scanvac, but we have a very tight cooperation together. And then there is also industry collaboration. For example, following up EU regulations to include high Nordic quality product performance standards like heat recovery. But Juhani will later on today talk about these issues. So this was a very short overview of the cooperation ongoing at the moment. Thank you.
Yes, thank you, Siru. Very nice overview of the situation at the moment. And as all of us, we can see that there's many activities going on in the Nordic level here. And it's a little bit amazing even how much new activities we are created during the last couple of years at the Scanvac level. And you can see more information for Scanvac webpage of the activities of NVG or other groups and publications there. So thank you, Siru, once more time, and I think we have to move on with the program. And next speaker is Kim Witchen, and he will talk about update the weather data for design.
Thank you. The question for why do we at all think about updating the climate data in Denmark? Some of the reasons, or some of the reasons, is that we have seen very high temperatures in some new buildings over, especially of course over hot summer periods. It might not be caused solely by climate changes or hot summers, but maybe also by poor design. But even though it was requested by the building industry that there should be an official extreme climate, so that was the reasoning for setting up a new climate data set in Denmark. What we did was that we took or got measured data from the Danish Meteorological Institute, from a weather station located at Sjælsmark, some 25 kilometers north of Copenhagen. And we used that for two purposes. One, to create extreme data files, and one, to create projections of future climate for the 1950s and 1990s, using the IPC scenario 5.8, assuming that we have business as usual development of the CO2 content in the atmosphere. So that was the reasoning behind it, and Sjælsmark is located here at the blue arrow. It was supplemented the data from Sjælsmark with data from nearby stations, because in the early period data was measured from the period from 2001 to 2019. And in some of the early periods, not all data that we needed was included in the Sjælsmark data. So we got information from some of the nearby stations to supplement data from Sjælsmark, and in that way create a full data set with measurements from the 19 years. The first thing we did was to create extreme data, and we created actually 4, and the two of them is the extreme hot and extreme cold weather. So we took the 12 months with the highest and the lowest temperature and put them together, creating a full year with some smoothing around the shifts from one month to another. And the purpose for this is to enable building designers to use them in analysis of a building's resilience against extreme temperatures. So in that way, we can really have an extreme weather data set to use in this kind of analysis. Of course, this should be used in combination with the data selected for the most sunny or most cloudy month, which was the other two extreme data sets that we created. So here is data on the most sunny and the least sunny month of these 19 years of measurements. And this can be used for resilience analysis, especially with focus on solar radiation. But again, it should be combined with the coldest and the hottest period climate data. So this was what we selected from just from the 19th years of measurements. If we try to compare what we got from this extreme data, you can see here at the right hand that we have the average temperature of the hot and the cold years, and they deviates quite significantly from the average temperature of the current design reference year 2010. But on the average temperature on the sunny and the cloudy years do not deviate that much from the average temperature. Though, of course, we have some extreme temperatures that are quite different. On the solar radiation, on the other hand, the hot and the cold is not that far from the standard year, but the sunny and the cloudy year is up to almost 24% more solar irradiation than the standard year. So this is kind of a little simple statistics on what we got out of this 4 extreme years that we created for the building industry. Then we went on to try to create projections of climate data, and we, in that context, we use data from the Cortex project as basis for the projections, and the Cortex data is projections of European climate in a global grid of 150 to 600 square kilometers. And we could use that to scale to a local grid or regional grid of a maximum of 100 square kilometers. And to do that, we needed, at the best, 20 years of measured data, and we had 19 years. So these 19 years was fit into a routine where we could create these regional data. Further to that, we made further corrections by bias correction. So we took the measured data and created projections for the last year of the measured data, and then compared the projections with the real measured data for that these years, and in that way made a bias correction based on the measured data. Some issues about the Cortex data: it do not contain information about wind direction. We use that in dynamic simulations. So we have supplemented data with this kind of information based on historical measurements. So we actually took the wind velocities every month and try to use the same month from historical data and impose wind directions on the projections of the wind speeds that we got out of the project, the Cortex project. Additionally, atmospheric pressure was not measured in the first years of the analysis of the measuring period, so we had to take these parameters, so they are quite uncertain in the projected data. So we are actually missing this kind of information. And again, we use the atmospheric pressure in dynamic simulations for analysis of natural ventilation. So we needed to have that into the climate data set. And last but not least, we should consider that these projections of climate data is typical meteorological years, and in contrast to design reference years, it may not contain so many extremes as we would see in specific years in the future. So in future, this might be we could call it a gray average with less extremes than we see in real years in the future. If we look on some statistics on the projected climate data, you see at the top the green lines on the top. It's the standard design reference year with minimum mean and maximum values for temperature, wind speed, and atmospheric pressure. And you can see that in the temperature is the average temperature is increasing over time, and at the same time it seems that we have a drop in solar irradiation, and it fits quite nicely with the IPCC projections of our future climate. It'll be hotter and it'll be more cloudy. So in that way, the projection seems to fit with the IPCC projections. It seems that wind speed is decreasing over time until the end of this century. This is not in line with what is expected in the IPCC predictions. So this might be a flaw in the model that we used to make the projections of the future climate. And of course, this data sets can be used in analysis of buildings' resilience towards future climate, at least in an average. But maybe the extreme data sets that we created based on picking from historical measurements might be better suited for extreme conditions in future climates. We created this 6 data sets, both for our BE tool in Denmark. It's the tool that we use for applying for a building permit to prove that the building is in conformity with the energy performance requirements, and also for proof of thermal indoor climate in residential buildings. Additionally, we created climate data sets for the BSIM, which is a dynamic simulation tool used for analysis of buildings and installations. It's commonly used in Denmark for proof of thermal indoor climate in non-residential buildings. And last but not least, we created text files with formatted according to the Energy Plus dynamic simulation tool. It's an American tool. It's often used in Denmark for proof of daylight conditions in non-residential buildings. So these formats of data sets have been created and is available on our websites. So that was kind of the short story about the reasoning behind creating new updated climate data and how we did it.
Okay, thank you, Kim. And I would like remind you, all the participants, that you can put your comments or questions in the chat. Chat is open, and in the end of this webinar, we go through your questions or comments. Okay, but still before the break, we have one more presentation. Peter Brander will talk about Swedish experience of OV core methods.
Thank you. Well, I want to show you a brief presentation on what's going on in Sweden regarding the use of smart sensor systems in tracing performances in ventilation systems. And as many of you already may have heard, we have a system called OVK, Obligatory Ventilation Control. There's been a investigation ongoing in EU according to the EPPD directive that was produced a year ago on mandatory inspections in ventilation systems. And the recommendation is that some sort of mandatory inspection should be applied according to in the EU in some sort or some way. So we can expect something in this area in the future. There actually are some pretty detailed standards about inspection of ventilation systems already, but they're not mandatory in the different countries. And for in Sweden we have the OVK system, and that's part of the standards or some parts of the standards. And the main idea about the OVK system is that you have a first inspection when the system is new to make sure that it's functional, and then you have some repairing regularly inspections that occurs 3 to 6 years in between to prove that the indoor environment and the ventilation system is functioning as it should be. And we have had this system ongoing since 1992. And most buildings for residentials and official buildings are included in the system, has to have a mandatory inspection about 3 to 6 years cycle, depending on how complex the system are. And we apply this by a third-party inspection with certified inspectors. So we have around 1,200 certified inspectors in Sweden that does this. And the result of these inspections are sent both to the owner of the building and to the local authorities to make them able to follow up in correcting faulty systems. In this process or this certification scheme, we have an organization for the certified people that's not mandatory, but a lot of the certified inspectors are included in the system. It's called Funkis, and they have made some more guides, more detailed guides on how to perform the inspection. And we also have our branch on ESIAC, it's called Svesiak, and that has put up some also control guides on how to inspect faulty ventilation systems when we have people that report health issues within according to the ventilation systems. So this is in place in Sweden, but it's not mandatory. What we can see from the OVK reports that's been sent to the authorities is that they often find faulty performance. And as you can see in these pictures, it's pretty obvious in some cases. So here you have a whole bucket of nails included in the ventilation. So the inspection have a direct performance enhancing effect. What we can see in the system in Sweden that often comes out as complaints is that we have because we have 290 different places to send the reports. There are some quality issues on how the reports are handled in step 2 from the authorities. So we have problems that not the building owners that's not controlling the system, they don't get any follow-up on why they don't control the systems. And if they have made controls and they have faulty systems, the follow-up sometimes isn't good on that the corrections actually have been made. So for the building owners that have a good quality work on ventilation system, they often feel that it's a very expensive system that doesn't provide them with any more information on how to make their system perform any better, because it's 3 to 6 years in between. And they also have issues on that different inspectors or certified inspectors can come to different conclusion on the same system, because it's hard to measure airflows or different kind of inspection problems. And we also have in the system that we inspect on how the building was intended to be used, and we don't inspect according to how it's in some cases misused and used to different or other purposes than it was intended to. So that's also something that if you're going to implement it in your own countries, you have to think about, or maybe can do a little bit different. But what we see now is that more and more systems and actors are trying to optimize the energy use in the buildings, and they combine that with much better measuring sensor techniques on securing that the indoor air quality and indoor environmental quality isn't poorly affected. So we see now in the best cases that the overco protocols, that's, as I said earlier, was made 3 to 6 years in between, now actually is fully automated and can actually be made every 5 minutes in the most detailed systems today. So the answer from the building owners is, how often do you want the results sent to you? And the shift into this sensor-based controls is, of course, that you can see tendencies and variation between systems in a whole different resolution, and then an on-site inspection every 3 years can give. So this is a much better way of knowing your system because you get a lot of more data. And here's an example for one of a bigger setting of different building owners that have created a system for sensor-based follow-up, where you of course get back to the tail index that we discussed earlier. They have to choose some measurement points to follow, and then they make an index of how good it is. But we can see hour to hour and how good it is, and most often we can see that in some hours during the day the environment isn't good enough. But this maybe isn't a receipt on if it's a good or poor environment. Maybe this is more, this is more used like a starting point of an investigation. We have some outliers here that we have to learn about if it is a problem or not. And this is a new way of or a new possibility to trace with a better accuracy. And of course, as we talked about earlier, we have to decide, here's some research that has to be done, which index is to be followed, and which parameters can be sensor based or sensor followed in a good way. So the Aldrin tail has 8 different things to follow in the ventilation air quality. And some of them today is never measured. I should, and some in some cases they are. So we have to discuss this and come to a conclusion on what to trace. And there's also different research going on in other countries where they discuss how to present the data on how an indoor environment is performing, so that the decision maker, the building owner, actually understands if it's good or bad, and when the problem occurs. So there's a lot of interesting research going on, and one of them is done by Annex 86, which can be openly followed as well, where they have a special project now ongoing between 2020 and 2025 on exactly this issue, what to measure and how to measure air quality. And since the actual presentation of World Health Organization's new guidelines actually is to be presented tomorrow, I just wanted to show this to you as well. So the researchers is gathering the information on air quality in a fast rate now, and that's been done a lot during COVID that we will hear more about later. And to be able to do this in a automated way, we have to learn and how to present which one is getting what kind of data from who and when and in what format and so on. So in Sweden or in IT systems, we call this modeling, to be able to describe in the process of data communication, to be able to do this in a proper manner. And this work is underway in Sweden now to be able to be more precise. So to use more automated system and use sensor data is a very good idea to learn more detailed about the system, but only if you have sensor data you can rely on, if you can act on the data. To collect the data and present the data is nothing if you don't act on the data. And you also have to have a system that can act on data that isn't presented, that should have been presented. So that's something to take into consideration. And if we start to get more sensor-based measurements, we already see in Sweden today that we get a whole different set of statistics on what in the system that doesn't work and how often and so on. So there's a lot of different research projects going on in the EU and in the world and in Sweden and other Nordic countries that where we can see that actually we have to make some ground research on data mining, on how to use all this data that is now being generated. And the Internet of Things, the price of doing this is rapidly decreasing. And in Sweden, we also have projects ongoing now on how to verify pressure sensors, for example. That hasn't got a good quality standard of how to test the sensors. So there's a lot of interesting research going on. And that's a little short introduction to IoT and how it's developing rapidly right now.
Okay, thank you. I think we are quite well on time here at the moment. So I'm just looking for the chat here. There is some question about ductwork, but maybe we can come that for the later. But there is one question about this weather data and dealing with building simulation and weather data and calibration. So maybe Kim, that is maybe something for you. Do you have any plans to use local weather data for calibration or simulations? Or if you read it to chat here, do you have anything on something like that going on your country?
I mean, everybody can use local weather data, but these are the ones that we created as official data, so and considered more or less valid for the whole country. And of course, there are, even though Denmark is a small country, there are big differences between coastal and inland, especially in terms of wind, but also solar irradiation is significantly higher in some places than other. But we have not created as such weather data for local conditions.
maybe also have a chance here to ask him a question, because we also have a project going on for the weather data and improvement that, and you are now improving weather data for the heating energy consumption, or both heating and cooling and overheating consumption, both?
Both, yes.
Yeah.
The BE tool is considering both heating and cooling and overheating.
What about building physics? Because that's the other thing, because the moisture load and rain is also the other thing which got quite hot topic in Finland at the moment.
A colleague of mine have just started a project on creating new weather data files for moisture calculations. But it's in the early days, so there's no information about it yet.
I also, because I have a chance to ask it, do you have official weather data for cooling calculation in Denmark?
It's the same data set.
Is a test reference years that you're using there?
Yes.
Okay, it's not like an AS rate. There's a specific weather data created just for cooling calculation.
No. We have one data set used for both heating and cooling calculations.
Because normally test reference years are made only for heating purpose, not for analyzed for cooling. So it's a little bit other topic.
Yeah.
Okay, but I think we have now time for the break, and I will ask now for the Mervi and Siru, how much time we can have it here? 5 minutes or even more?
10-minute break.
Okay, 10 minutes break. So 2:05 Finnish time. So after 10 minutes, we continue. So just be tuned here. We continue after 10 minutes. Okay, I think it's time to continue. And the next speaker is Johannes Martin. Talk about Danish changes to the building regulations with regard to ventilation. So,
Riso, actually it will be Niels giving the presentation.
Okay, then Niels will. Okay, sorry, I didn't notice that. Okay, Niels, screen is yours.
Just have to unmute myself. Okay, thank you so much. Yes, well, it's a joint presentation from me and Johannes, but I will be speaking most of the time. Thank you for letting me be here. My name is Niels Brosvarming. I come from the Danish Housing and Planning Authority. We, among other things, have the responsibility, at least the technical responsibility for the building regulations. In the end, it's the minister's responsibility, of course. I will speak a little bit about some of the changes that are going on to the ventilation requirements in the building regulations at the moment. We have decided we will not be sharing the slides in a PDF version because these slides tend to have a longer life than they are actually intended to. We are in a process where we change the regulations at the moment, and maybe it won't be exactly what we are saying today, and that's going to go on for the next couple of months. So if these slides kind of like survive the next couple of years, it's not very good for us. So you can see the slides in the presentation. It's being recorded, so you can see it there, but we will not share them in PDF. Just to say, this is only a draft, and that's the main reason for not sharing it. Okay. We have been looking at changes for our regulations on ventilation for quite some time. About 1.5 years ago, there was a lot of discussion on the the ventilation requirements, and especially on some of our requirements that set some technological specific requirements that it should be mechanical ventilation in multifamily houses, schools and daycare institutions, and there was not really any very good reasons why there should be a very technology specific requirement if all the other requirements could be changed or could be fulfilled without using mechanical ventilation. So if you can keep the indoor climate in the right way without using too much energy, using other systems, that should be just as fine. So we did a small change last year because it has to go fast in that time, and then we promised a more general overhaul of the requirements, which is what we're doing now. The overall intention is to have a more neutral approach to technology, so as not to require something that makes it necessary to use a specific technology. And we also need to update the requirements to better reflect the market. So at the moment we are doing this. We're actually quite far in these changes. The requirements are currently under internal review, which means that there's some legal officers looking at the requirements from a more legal perspective, where Johannes and I, we work with the requirements. We are engineers and look at it more from a technical perspective. And both of these issues has to be resolved, of course. So this is what's going on now. And after this, in a couple of weeks, something like that, we will go into a public hearing or a public consultation. We put these hearings up on this høringsportalen.dk, and you can go into that. It's in Danish, of course. I'm sorry for not Danish speaking. And we expect these requirements to go into force in January 2022. And we also have an updated guidance document that will follow this, probably also expected in January 2022. So when we change some of the requirements, we need to, of course, update our guidance documents as well. So that's the timeline for this. I'm just going to go through the larger changes in this, and one of the issues is operations and maintenance. We have already a requirement in the mandatory standard, the DS 447, that requires that there's sufficient space for operation and maintenance, but sometimes the requirements have more power or a higher weight if they are in the actual building code. So we're not really changing something from a legal perspective, but we are kind of like moving some of these requirements up from the standard to the actual building code. And in our experience, that gives something more substantial weight, and there's a more focus on it. So actually, in a legal terms, it's not a actual change. So, but on humidification, we're doing an actual change. At the moment, the requirements are in a way that actually humidification in the ventilation system is forbidden, except in very specific cases where conservational health issues makes it necessary to humidify. It's normally in museums or maybe in the ward in the hospital that treats burns, where you need to have a high humidification or at least have control over the humidity levels in the building. Then it's possible, but in most cases it wouldn't be possible in the current regulation to use humidification. And we have been discussing this quite a lot, both with the industry in Denmark and in this ventilation group in the Nordic countries, and we come up with the conclusion that actually we don't know why the requirements are in the building code. We couldn't find the history on this, and Hans and I have not been there, any of us, in more than 8 years, and the requirements is older than that. But we believe that it's a microbial growth issue or a bacteria issue, and of course you should be able to use something humidification if you can make sure that it doesn't poses any risk. So we're changing the requirements so that if you use a humidification unit, then you can do it if it doesn't poses any risk to the health or comfort of the users in the building. Yes, so it's a not so strict requirement as it was before. For ventilation in residential buildings, at the moment we have a requirement that the residential ventilation should be at half air change rate at all times. Well, actually it's 0.3 liters per square meter per second, but it corresponds to about 0.5 air change rate, and you should have that at all times. But maybe that's not really necessary at all times. What if people are going on holiday for 3 weeks? What if there's nobody home during the day and all the moisture from the sleep has been ventilated out? So we are proposing a change that this can go down to half of this ventilation that you normally have when the home is not in use. It actually follows the default values in the European standard on ventilation or on indoor climate, I think it is. All right. And we also have a requirement for CO2 levels in schools and daycares, and actually this requirement for how much ventilation there is based on both an airflow per person and per area, as well as a CO2 requirement. But actually you could have the idea that if you only fulfill the airflow per person, that you will fulfill the requirement, and that's not really the issue in most cases. Most cases it will be the CO2 level that will be the most difficult one to fulfill. So we are removing the airflow per person and per area, and just keeping it to a total CO2 level requirement. Okay. We use a Danish standard in the building regulations. It's mandatory, DS 447. It's under revision, and it's expected to enter into force at January 1st. The new version is expected to enter into force at the same time as the new building regulations on the 1st of January 2022. So this follows each other. I'm not going to go into the changes in DS 447, but just to let you know that that's changing as well. And we have other smaller issues in this as well, in this requirements. We do have some areas or some regulations in this that has different uses of language, and sometimes different uses of language can be misunderstood. So when we use two different wordings of the same issue, people start asking, why do they actually use different language? And in most cases, this has been because of the different changes during the years, and people only changing kind of like one paragraph somewhere. So that's one of the issues that we are kind of like going through the whole chapter in one take and aligning the language to what is normally used. And then we do have some requirements that uses examples. For instance, the humidification requirement says that it could be, for instance, museums or printing offices, whatever that's called in English. But when you use examples, where you can sometimes get the idea that you have to be close to that. So sometimes using examples doesn't really help. It just closes some of the possibilities for doing this. So we're removing some of these examples as they can be kind of like can minimize how much you do, and that's not really the idea behind this. We do have quite a lot of places in the requirements where we have to make smaller clarifications where things are not really clear. We discussed this very detailed with the ventilation industry in Denmark, and we believe that together we come up with a very good language of these requirements and very precise requirements that let's see when they actually go into force if they are, but we believe that they are better than what we had before. And last but not least, as Siro said, there has been a lot of discussion on exhaust hoods in Denmark, and we are changing the requirements for the exhaust hood as well to better fulfill some of these issues that we have in Denmark. I'm not going to go further into that because nobody has actually seen the future requirements, and it will not be published until the public consultation. All right, that's actually what I was intending on saying on the ventilation changes. I have a few more slides, but it's on something that goes a little bit further because at the moment it goes into ventilation as well, but at the moment we are looking at a voluntary sustainability standard in Denmark. It's a standard that tries addressing some of these issues that are within sustainability, the environmental sustainability, the economic sustainability, and the social sustainability. Sorry, and we've been working with this for quite some time, and at the moment we are testing this voluntary sustainability standard over 2 years. And actually the goal is to implement these criteria for sustainability into the National Building Code from 2023. So this is actually something that are going on at the moment, but will be implemented in the building code in about a year and a half from now. We are evaluating these requirements at the moment, but we don't really know in what form or if they go into the building code. Is it the same? Is it all buildings? Is it only some of the buildings, etc.? A lot of these things we haven't really answers to yet. However, there's been produced a national strategy for sustainable construction, and at least the LCA requirements, which is the cornerstone of the environmental sustainability in this class, has been decided that it will go into the building code. I will just come back to that in a minute. But we are testing 9 requirements for sustainability at the moment. The LCA requirement, which incorporates the whole life cycle carbon emissions from the building process, from the product phase of the construction materials, from the use of the building and the end of life. And we also have requirements for the total cost, the life cycle cost. And some of these social sustainability requirements are interesting from a ventilation perspective as well, because we are testing off requirements for noise from ventilation systems. At the moment, we have a requirement in the building code in homes that says that it must not be above 30 dB, and we're testing off a requirement that takes it further down to 25 decibels. So maybe that should go into the building code as well in a little bit more than a year. And something else, we do have some requirements on how to use emissions from building materials and how they are emitted, but we use ventilation, of course, to remove some of these emissions. And we do also have a plan that you need to have a plan to make sure that the indoor environment is good at all times for this building. Just to let you know that there's something going on in this area. So the national strategy for sustainable construction, I'm just taking this slide with you. I'm not going to go through it, but in the bottom you can find it if you want to look further on it. The most interesting in this is probably that we are trying to change some of the focus that is on we have been focusing a lot on energy efficiency over the last 20 years maybe, but we will shift our focus a little bit. We will not stop focusing on being energy efficient, but we will take another look on the requirements, and we will get them to be more focused on LCA. And actually the parliament has decided that we need to go for LCA requirements in kind of like a stage phasing in of these requirements. So actually already from 2023 there will be requirements for all buildings which are part of the energy performance of buildings, that they have to calculate an LCA if the new construction are above 1,000 square meters. You need to live up to a threshold limit of 12 kilograms CO2 equivalent per square meter per year. And the plan is that this requirement will go down in 2025, 2027, and 2029, so that there's a decreasing amount that you need to live up to. And on top of that, you have a voluntary CO2 standard that you can voluntarily go into as a investor. Yes, I believe that was what I had intention of saying. Yes.
Okay, thank you, Niels. And because we are quite on time here, we have time for a couple of questions. Here is two very specific questions for you for Denmark. That have you considered a heat recovery for humidity side in your regulation?
If you can use enthalpy, yes, change, what's it called, heat recovery. Well, if we have considered it, we know that it exists. I believe that the requirement in the DS standard is that you should you should consider the heat recovery without moisture recovery, but of course it goes into the efficiency of the heat recovery unit and also the moisture recovery. But at least for housing in Denmark, a lot of the time of the year we ventilate to remove the humidity. So if there's actually a recovery of the humidity, maybe in some times of the year it can be a problem. But we look at it. Of course, we know that it exists, and I'm not quite sure whether or not the Danish standard on how to put the heat recovery in is on dry efficiency. I don't remember. I believe it is, but I'm not quite sure.
Okay, here is the other very specific questions about CO2 requirements in homes and offices. What do you have in Denmark, or do you have any specific demand?
For schools and daycares, we have 1,000 ppm. For homes, we don't. We have this half an air change per hour. And for offices, we have a guidance that says that you can live up to this requirement by building according to, well, at the moment we are referring to I don't remember, it's the class B in the 15 to 51, or you can be below 1,000 ppm. So that's the normal way of doing it in Denmark, at least, is to make the ventilation system so that under the dimensioning conditions, then you are below 1,000 ppm.
Okay, maybe I take one. There is a specific requirements for bathroom, kitchens, or bedrooms. Do you have any plans for those?
No.
Ventilation air flow rates? No.
No. We are keeping them as we have them now. Yes.
Okay, thank you. Maybe we can continue in the discussion part. And next speak is Juhani Hyvärinen, and he will talk about how this wide cooperation across the sector for industrial point of view works. Juhani, screen is yours.
Juhani, open your microphone.
You're muted.
I was sorry about that. Yes, hello, my name is Juhani Hyvärinen, and I work for Finnish Building Services Industry and Trade Association, and the short name for that is Talteka, originates from the Finnish name. In Talteka, my role is to monitor the technological needs and trends and regulatory changes in the society, and based on these to find out if there is any need for some kind of common activity related to these matters. So quite broad sector. In this cover slide, there is a list of names in the industry group that forms the industry group. I have been participating in the project here, and I was asked to give some points or topics of common interest related to this project and Nordic ventilation guidelines. So we have an ongoing working group or a group consisting of these persons here listed, and we meet quite often in teams, and have also discussed the results that we have seen from this project. And I'm here only a speaking person, nothing more. But I hope that the next slides will give you some kind of idea what we have found out, and what we think is relevant in the project and perhaps in the continuation. So first of all, this project has been very welcomed It has a very wide participation base, stretching from users of buildings represented by one association, and then, as Siru already showed, authorities, academia, industry, and also trade. The list on the left is a free list, and for example, health authorities has not been so active here, but perhaps they should be more active. In Finland, at least, these are two separate sectors. The regulation when the building is being built, and the other sector then when it is being used. So the sector is broad. There are lots of different actors, players in the field, but also the needs on the right-hand side, they are quite complex. Of course, the most important part is the indoor air quality or indoor environment quality. To provide the people with good indoor air. Of course, it means to produce that it needs to be warmed up, it needs to be treated, it is produced in the building in a way. It is not delivered from some kind of central plant, but it is produced in the building. So energy, it consumes energy, and energy efficiency is one key issue here, how to do it efficiently without using too much energy. Then there's a direct link from energy to carbon footprint. Already in construction phase of the building, and then also during the using phase of the building. No building can be used energy efficiently or in a correct way if it is too difficult to use. So one issue is also how to use it in an easy way, how to use it, how to switch between away, at home, airing stage, how to use automation in using the building. These kind of things. Also the issue of easy to construct, digitalization, maintenance and service, and then various systems in the buildings, they have to operate correctly. It's good to discuss these kind of issues and topics on a broad basis. So this is one of the reasons why this project has been a good thing, and it has offered a good platform for discussions. So welcomed in that way. Ventilation tradition in Nordic. I think we all recognize that there is a tradition here, reaching out perhaps 100 years in the history. And we like to think that it is different from many other market areas or climatic areas. So there's a Nordic ventilation tradition. The things listed here are partly not based on facts. They might be just explanations why things are like they are. There might be other reasons, but the ones that come first in mind are the climatic conditions. We share similar climates here. Of course, from Iceland, top of the Norway or top of Finland down to southern part of Sweden or Denmark, there are differences, but there are similarities as well. It seems so that good ventilation in these conditions, it might require mechanical solutions quite often. At least they have their benefits. cold winter might give some challenges to natural ventilation in the form of draft, and warm summers, the airflow, air change rates might be lower, so it has to be controllable, and there are reasons why big part of the buildings are equipped with mechanical ventilation systems. Here also the energy efficiency plays an important role. A big part of the energy consumption in the buildings is caused by the ventilation. You need to heat up the air, supply air to the building, and it's good idea to take recover the heat, recover the energy back before exhausting it back to the environment. So there are some main requirements, in my opinion, or in our opinion, that might be the reason for the ventilation tradition here. But then the question, do we need similar rules, or do we need same rules or same regulation? And I think the one kind of conclusion here was that instead of same rules, same regulation, it's good to have discussion, good to have information for inspiration for regulations. So positive, competitive regulation. So we learn from the neighboring country, neighboring place, neighbors, and to so that get ideas how to improve the regulation in a direction that gives a better result. Well, we don't know. We cannot say what is the right answer here, but I think this is one of the key outcomes of the project. So we are expecting it very keenly to see what this cooperation this year can pull together. And of course, we hope that similar rules or similarities can or could make it possible to apply same solutions and same products in all Nordic countries. And in regulation, it is always good to remember that regulates what, not how. So CO2 level, not quite technology. Okay, then the next thing we discussed, or one of the things we discussed, they are not in the order of discussion, of course. But cost of construction seems to be a concern for all, not only for us, but for all in the society or in the countries. Here we have a kind of a semi-joke or half joke that if you have only a little money, you can't afford to buy cheap. So quality has its price, its cost, but on the other hand, you need to remember that, and you have to remember that good quality does not need to cost more. It could be the opposite, actually. The heating cost might be higher than expected. The indoor quality is very difficult to judge by a user in the end of the day. So it's really difficult to judge whether the quality is good or bad. So quality deviations are difficult to find out, and they are also quite difficult to repair when the building is in use. And also one must remember that productivity and the indoor air quality has some kind of a link, and saving in wrong place might lead to less productivity or decreased environment in a home. One way, of course, to tackle to touch the cost is to have a kind of idea of bigger market, the scalability of solutions, scale of the production, and so on. So if we have a larger Nordic market, perhaps we could use the same solutions in different areas of Nordic countries. Also more impact through research and development. If you can learn from others. Product approvals and solution applicability. So you only need to have one certificate or type approval to be able to use it in other country. Of course, then benefits of scale in production, and last but not least, the training of installers and users. They are normal people who use and install our products and our systems, and if there are similarities, the training education is much easier. And as a basis for all this, clear and transparent regulation gives good foundation to develop products and solutions so that they would fit in a large market. So these are ideas of this around this topic of cost. How to get better quality without too much cost. Okay. And one interesting area or topic is also the European level regulation. We are part of European Union in a way or another. There are differences also here. But as an area, climatic area, we present really cold, or we are countries that belong to cold or Arctic climate zone. And from this point of view, it is very important to at least follow up the European regulatory work, so that we would have such regulation from Europe that would fit also here, that could be applicable here. There are good examples from the history that we get something that we really cannot use, or it is difficult to apply. On the picture here, right, the brush has been so thick that it is really difficult to see the differences and small details. But in this kind of cooperation, one takeaway has been that we have been able to compare regulation in other countries in Nordic, but why not to go further and compare regulation in Europe? So if a solution works somewhere else, would it also work here? And if a solution works in Nordic countries, could it be applied elsewhere? There must be good practices, good solutions that can be exported and imported. In short, good ventilation level requirements of the Nordic countries should be maintained, also in European regulation when justified. Health, noise, comfort, and energy, and there are lots of other characteristics that we have been quite successful. And during the last 2 years, the building services have had a key role in maintaining the clean indoor environment where the risk of infection is low. So good ventilation flushes viruses away fast, and that is very important also to remember now and in the continuation. So the next topic of common interest in our discussions was the digitalization, and it is really a good possibility to save costs during the life cycle of a building, in the delivery chain or in the construction phase of the building, down or throughout the building management during the building use phase. There should be, or there could be, common product information for design, trade, and use, like product information templates for digital systems and such tools, digital tools. And as a major guideline, one piece of information stored in one place only. The picture on the left is blurred. It is intended to be blurred. I think the digitalization is only is in the discussion now, but not a clear vision. There is no clear picture of what it will be. We are looking for the right arrangement or right level of how to do things. For example, here lots of these small databases, and they always mean a copying of a piece of information. How to prevent from that? Building information models also is a good way how to make construction easier. How to make digital twins for its purpose, design, construction, maintenance, or how to model indoor equality or indoor condition data model, as it is called. But of course, there is a risk of increasing the burden for different actors. Maintaining the data integrity from day one. So how to be sure that the data that is in one of these containers here is always the correct data. There might be, and we have already noticed that there are overlapping schemes for product approval. Well, for one product, you need to have two or more certificates or similar things to show that your product is applicable or has certain quality. And then there are also competing schemes for product assessment. Especially the newcomer in the field is environmental product declarations and environmental product labels related to these CO2 emissions, for example. How to show that what are the emissions from your product during different phases of building life cycle. So there might be some extra work which should be avoided. For an average user, it is important to be sure that it works, or does it work? And the answer should be yes, it works. It is almost impossible to see if the ventilation works or if it doesn't work. You cannot see the air or impurities in the air. And you get used to bad air quite soon, so that's a difficult task. And there has been good initiatives, good procedures, practices in ventilation inspection, or if it's called ventilation control. They might be obligatory or they might be voluntary, automatic or manual. They can rely on sensors and continuous monitoring or automatic monitoring. But point is, it's good to check now and then if it works, because it is difficult to see if ventilation works. On product level and on system level, it is good to remember that transparent requirements help. If you know what is required, it is easy to show and it is easy to certify that this product or this system, this solution fulfills its requirements that are transparent. It's benefit that you don't have to certify, but for sure it's a possibility that you can use a certificate to show your quality characteristics in a reliable way, and this might help in answering the question, does it work? What we noticed in this project was that in the beginning we thought that there might be more product regulation in Nordic countries, but in the end we noticed that there is not much regulation at all. The product can be put to market in all countries. There are some differences, but no major ones. I think I have used my time, so thank you very much. And as fast conclusions, we see that there are more similarities than differences. Instead of obstacles, there seems to be a number of interesting topics for common activity, which should be continued. How to learn from neighbors. And perhaps designers and consultants' voices could be louder in this cooperation. Contractors and wholesalers as well, but designers and consultants might be the next group to get into the project. And how to respond to new challenges together, like a COVID pandemic or prevention and mitigation of climate change. Small questions or big ones, but something to do still. Yes, thank you very much. This was my presentation here.
Okay, thank you, Juhani. I cannot see any direct questions at the moment for you, so maybe we can move on to the last presentation and then coming back for the questions and comments in the discussion part. And we have still one more talk here. Lars Ekberg will talk about reducing risk of spreading pathogens. So maybe after that we can have a lot of questions or comments in the chat. So Lars, floor is yours.
Thank you very much. I will soon find oh my, I'm sorry, but I'm looking for the presentation. I'm sorry. I have to close down some things here. As you heard previously, I'm connected to Chalmers University of Technology, and I also work at one of the subsidiaries to Chalmers Industri Teknik. So I am partly a researcher and partly a consulting engineer. This is here it is. I'm so sorry for that. Is there any chance that you see my first slide here saying reducing risks of spreading pathogens in indoor environments?
Yes, we can see it.
That's good. When talking about reducing the risks of spreading pathogens, I think it is obvious that a good starting point is to think about the possible ways of transmission, of course. And I think that you all are aware of these three pathways. There could be a transmission that is airborne, it could be a droplet transmission, or it could be a matter of contact transmission. And this figure, I found that published by the Japanese Association of HVAC engineers, and I think it's rather nice showing what it's all about. When this infected person coughs, for instance, a wide variety of particles in terms of size are generated. Some of these are really big, so they deposit almost immediately. They fall to the floor or any other surface immediately. Some are of an intermediate size and actually could be, due to their inertia, transmitted directly onto the mucous membranes of the susceptible host. And some are smaller, of smaller size, so they are dispersed in the air, spread in the air, they become airborne and could be inhaled by the susceptible host. So by knowing these quite simple things, we really immediately realized that some face mask would probably help. Washing hands would most likely also help. But in the case of airborne transmission, ventilation and air filtration should also be expected to help. And if it's a matter of measles or tuberculosis, it's a matter of pathogens that definitely are very much airborne. And the virus that causes the COVID-19 disease are perhaps not airborne to that extent, but at least to some extent. So for the rest of this presentation, I would like to be a little more general. So we are not talking only about the SARS-CoV-2 virus. So it's a little bit more general, perhaps in order to help us being more prepared for the next pandemic event that might strike us. I thought that perhaps we could try and learn something from another field where professionals are really used to working with reducing risks of spreading pathogens, and that is from the clean room side. For instance, manufacturing of within the pharmaceutical industry, or operating theaters, protecting operating wounds, surgery wounds, and see if we can find some cornerstones to build on regarding finding good methods and solutions for residential situations and offices and schools and other non-industrial situations. So clean room technology as a starting point, we can soon realize that within the field of medical surgery, protecting the surgery wound, that we have long experience from that began more than 100 years ago. Cleanliness technology, at least. Perhaps you couldn't talk about clean rooms here, but that is a field that certainly has developed over recent years as well. And during the 1960s, the field of the pharmaceutical industry and clean room technology in that context began to be developed. And medical surgery and pharmaceutical industry, that's situations where you really need to address the risk of spreading pathogens. So this is one immediate question that arises. How clean does the air need to be if we talk about the airborne transmission side? And in the field of the pharmaceutical industry, there is actually quite clear requirements. You know what to aim for. As an engineer designing a clean room facility, you know how many particles per unit volume of air that would be allowed. This is an area that to a large extent was developed in the United States. So in early documents from this side, it is not SI units. So FT3, that's cubic feet. 1 cubic foot is about 28 liters or so. And we can see that within pharmaceutical production and transplant surgery, that's two situations that requires the second most stringent cleanliness class, you could say. There are lots of other reasons for creating clean rooms, but pharmaceutical production and transplant surgery requires really clean air. And working with quality assurance within pharmaceutical applications, you work according to so-called good manufacturing processes. And you talk about GMP grades, grade A through D, where grade A is the most stringent, the toughest requirements, where you actually create an aseptic environment. Where grade D, you are not required to create an aseptic environment in itself, because you sterilize the product you are handling terminally. And if we compare that to surgical operations, grade B corresponds to orthopedic surgery and grade D, other general surgery. And one remark is that it's actually, in one way, not that complicated to work with GMP requirements, because the requirements really are clear. You know what to aim for. It has been decided, and it's to a large extent standardized. You are required to consider particles larger than 0.5 microns and larger than 5 microns, potentially bacteria-carrying particles. Don't try to remember these figures. I just want to illustrate that this is to a great extent standardized, and you know what to aim for. The requirements are rather clear. And it's not only a matter of reducing or limiting the particle concentrations. This is the number of particles per cubic meter. Also, the concentration of microorganisms is made requirements on explicitly. In colony forming units, this is viable particles. And this is airborne concentrations, but there are corresponding requirements for microorganisms that has deposited on surfaces. So there are, if you work with quality assurance of clean rooms, like within the pharmaceutical industry, there are a set of mechanisms that you have to consider and be aware of. And the first one is the generation of potentially pathogen carrying particles. It's a matter of choosing the right garments to dress properly, to behave properly in order to limit the particle generation, and make sure that the processes you use in your laboratory does not promote the spread of particles within the room. It's a matter of ventilating properly, to filter properly, make sure that air moves in the proper way between rooms in order to ensure that the room which really has the highest cleanliness requirements is maintained the cleanest room, and that the air movement within rooms is proper in order to remove contaminants in an efficient way from the room air. And it's a matter of cleaning surfaces with the right procedures and with the right frequency. So yeah, I have a few reflections on each of these items on the following slides. So the first one, minimize the particle generation. I think you are definitely aware of this, and if you have read about the COVID-19 in various ways, perhaps you already know that if you move about a lot, if you speak loudly, or if you sing, you generate potentially pathogenic particles to a much greater extent than if you stay quiet or stay calm, move not that much. So this is the first cornerstone in creating a clean environment in the clean room. Wear protective clothing of the right quality. Definitely wear a face mask. There is no doubt that you should do that. You cannot enter the clean room, without a face mask, and behave properly. And really important, and you will see this on, I think, all of the next slides. This is verified by measurement. In this context, frequently the concentration of bacteria that could be deposited on the outside of these clothes actually is being measured in order to make sure that the clothing is properly put on and of the right quality. And then we come to the ventilation. First, okay, the grades. In grade A, very stringent dress code with fully covering suit and a face mask and so on. And in grade D, not that special requirements. Some requirement on the garment, but not that tough. And regarding the ventilation, in grade A, actually you could be required to maintain several hundreds of air changes per hour. And I don't say that we should learn from this side and try to achieve that in schools or offices. That is not the point. But actually, I have seen some situations where there has been an attempt to create a unidirectional airflow across a room, like a landscape office or so. And that is, I would say, you are deemed to fail if you do not make sure that this unidirectional air movement reaches about 0.4, maybe even more than 0.4, 0.45 meters per second. And if you're about to achieve that, actually the air change rate will be several hundreds of air changes. I mean, can you imagine that you cover your ceiling with HEPA filters and the entire ceiling is a supply air terminal unit. And if you need 0.45 meters per second in order to maintain this unidirectional flow of air, you will reach close to 600 air changes per hour. And you don't need that to remove the contaminants, but you need it in order to maintain the unidirectionality, so to say. Yeah, you are required to use HEPA filters for the three most stringent grades, but not in grade B. And on the next slide then, yeah, typically within the pharmaceutical industry, when HEPA filters are required, it's a HEPA filter of class H14 with well-defined requirements on its performance, and there is a requirement on the overall filtration efficiency, and there is also a requirement on the local value. So you actually you search for pinholes, you search for leaks. Really small holes that could actually leak more than what's specified. So again, it's very much relying on verification by measurement. This is a curve showing the filtration efficiency as a function of the particle diameter. Virus-containing particles could be really small single viruses, but they are most likely attached to larger particles. So I would say that we could find viruses almost anywhere in this size range. The HEPA filter is found here. We have a most penetrating particle size for HEPA filters, and we can see the most penetrating particle size for all of these filters. What do you say about this? If you really need to remove potentially pathogenic particles, which filter would you choose? Yes, if you could choose a HEPA filter, that's obvious, it's much better. But in a school building, is it reasonable? Probably not, due to high pressure drops. So if you would like to make a compromise, yeah, maybe an F9, F8, but even an F7 filter actually removes, you should expect it to remove more than 50%. For most particle sizes, substantially higher than 50%. Yes, I know that there is a new filter standard. F7 is according to the old standard. According to the newer standard, that is an ISO EPM 160% filter. So one final remark regarding this picture is that when the particle source is indoors, actually a sick person spreading pathogenic particles, then the filter has effect only if it's a matter of recirculated air. If you have recirculation of air, for instance, over or through an air cleaning device, a fan filter unit in the room. And then I would like you to remember that actually an F7 filter, or this EPM 160% filter, removes at least 50%, and you have to judge yourselves. Do you think that could be of any use? Would that reduce any risk? 50% go through, but you get rid of 50% of the particles. We can get back to that issue perhaps later on. Whoops. Sorry. What's happening? The next item in my list, air movement between rooms. If this is a production room that is meant to be kept really clean, you need to maintain a higher pressure in that room compared to the adjacent rooms. And typically in this field, you require more than 10 Pascal pressure difference, 10, 12, 15, maybe 20 Pascal, in order to establish a transmission of air in the intended direction. And this will work, of course, only if the doors are being kept closed. I have a slide later on, one of the last slides in this presentation, that will show what happens if you keep a door open. That will punctuate this air lock system. And again, this is verified by measurement. You measure actually the flow direction using some indicator, maybe smoke or some other device, to indicate that the flow is moving in the right direction, and you have surveillance of the pressure differentials between the rooms. The right air movement within rooms. You should make sure that there are no zones of stagnation. Maybe you think you have done your best actually with HEPA filters and all here, but actually according to this calculation of these are velocity arrows, you get some stagnation zone here with no air movement, and you could expect particles to build up in that zone. You could have obstructions. Here is a parallel flow. It's actually smoke visualization, a photo of a smoke visualization test with an obstacle creating a wake with a zone of stagnation. So within this field, we need to verify that you have obtained an air movement with no stagnations and no obstructions, and that you ensure a sweeping action, air sweeping, grabbing the particles and removing them in the most efficient way. Yeah, and the last of the cornerstones in my list, clean surfaces. Don't contaminate the surfaces. You should wear protective gloves, and you should not touch any surfaces unless necessary, and you should clean regularly by the correct methods. And also on this slide you see verification by measurement. Actually, here is someone taking a swipe sample, searching for any deposited microorganisms. So, to sum up, what can we learn from this? Yeah, it says verified by measurements. That's actually one common thing for all of these items. But here are the items again. And you will recognize all of these. These are part of, I think, all and any recommendations regarding what we should do in order to prevent the spread of COVID-19. Keep distance, keep calm, wear a face mask, ventilate properly, filtrate adequately, maintain barriers, airlock functions, ensure that there are no zones of stagnation, that the ventilation is efficient, clean surfaces properly. And by ventilate properly, of course, I don't mean that we should arrange with 600 air changes per hour, but as Reva expresses it, you should make sure that the ventilation system works as intended and that there are no faults in the ventilation operation. That is one very important first step, of course. Yeah, and in order to ensure this, in order to work in line with these, you could say, recommendations, we have some tools. We could predict the risk of the spread of disease indoors, and it's a rather widely spread model, the Wells-Riley model, which was established or presented quite long ago, where you can calculate the probability of infection or the fraction of infection cases in a population, and apply that to about any indoor environment. And by this modeling, you can study the influence of exposure time, how long you stay in a specific room, the room volume, and especially the various mechanisms of removal of pathogenic particles, the ventilation rate, the deposition, the activity decay, the decay of the activity of the virus, various air cleaning functions, and so on. And this is quite an early example of the application of the Wells-Riley model by Fisk and colleagues from 2003, where it shows clearly that increased ventilation reduces disease transmission. And this is not the COVID-19, of course, or it's just the common cold, I guess. On the y-axis, you have the sick leave prevalence. And on the x-axis, the ventilation rate. And here is an elaboration of those data with the sick leave prevalence as a function of the ventilation rate in liters per second per person. That maybe is a little more adequate. How much ventilation air you need per person that could spread the pathogenic particle. Some of you have definitely seen and maybe tried the Reva tool. It's an Excel sheet you could download from this website where you can test the Wells-Riley. You can apply the Wells-Riley equation for different settings. in this case classrooms, some open office plan at different ventilation rates, and in this case plotted the probability of infection as a function of the occupancy time. And there is also, this one is for a single compartment, one single room, but there is also a modeling tool that can handle multiple rooms. So you could model, for instance, a school with multiple classrooms, or an office, or whatever. You could model a residential setting, any type of setting. And the model considers the transmission of air between the different rooms, and you could place, like in this case, an infected person here. I think that you can also install air cleaners in certain rooms and calculate the probability of infection. I think that this model, the air that is transferred from a single room here, that is calculated as the difference between the air supplied through the supply air device and the amount of air, the flow of air that is extracted from the room. That becomes a transfer air. I don't think that yet this model can handle what happens if you leave a door open. And I will try to illustrate what could happen on my next slide. Here. If there is a temperature difference between these two rooms, H stands for hot, I believe, and C for cold, a warm room and a colder room. The warm air will rise through the door opening and the cold air will descend, and there will be an exchange of air, and an equal amount of air will leave this room as will enter the room from the cold side here. And actually we don't need a very big temperature difference before this air transfer becomes big, really massive. Just 0.2, as indicated here, this dotted line. Just 0.2 degrees centigrade will generate an air transfer of 25 liters per second from this room to this room and from this room back into this room. And if, I mean, this room, maybe it's a room that has a window and there is sun gazing in. It could be much more than 0.2 degrees. It could be half a degree or 1 degree or several degrees higher than in this room. Then we realize that this internal exchange of air could be really massive. So if you leave the door open, it could be in practice impossible to ensure that you move air from a room that you want to keep cleaner than another room. The air will be mixed very strongly. That is something to try and consider and have in mind when working with this. And if we put an air cleaning device in one of the rooms, as indicated here, I have measured ultrafine particles, really small particles, the blue curve, and also bigger particles, the PM10 measure of particles. In the first half of this test period, the door between this office room where the air cleaner was placed was closed. It's easier if we look at the ultrafine particle concentration. It's a nicer curve. And at this point, we started the air cleaner. Then it was a drastic decrease of the particle concentration from a little more than 4,000 particles per cubic centimeter, and it then leveled out shortly after at less than 1,500. I think it's a factor of 3, which you can actually calculate if you know that the ventilation air exchange rate was 3 air changes per hour, and the clean air delivery rate of this air cleaner corresponded to 6 air changes per hour, then you should actually expect the concentration to go down by a factor of 3. But here someone opened the door to the corridor, and what happened then? We lost a lot of this air cleaning effect due to this internal air transfer. And actually in this case, it was possible to quantify the internal air change over the door opening to 9 air changes per hour. So this is also something that could be worth considering. If you try to estimate or predict the effect of an air cleaning device, it might not be only necessary to only know something about the ventilation system airflow rate and the clean air delivery rate. It's also a matter of how the premises are used and how doors are being opened or closed. It influences the performance strongly. So again, I think this is my last slide. What can we learn from this? These are the same points, and these have been identified long ago, and you find them in the REVA guidance and in practically all other guidance in this field. Keep distance, keep calm, wear mask, ventilate properly, filtrate adequately, maintain barriers, ensure no zones of stagnation within each room, clean properly. And these are my final words then. There is knowledge available and there are tools available. And my suggestion, if you haven't done it yet and if you are interested, look at the REVA webpage and see if you can make use of those tools. Be aware that these tools, they are continuing being refined, not least or especially the input data. How could we really know that the generation of pathogenic particles, the quanta emission rate, really is the one we have assumed? Probably we cannot be sure at all about this, but the general judgment regarding these tools is that at least we have a fair chance to judge different solutions. We should not trust this probability of infection number in absolute terms, but definitely we have a good chance to judge the relative importance of different measures, like the relative importance of a certain increase of the ventilation rate or the use of an air cleaner of a certain capacity and so on. And from this, it might be in the long run possible to make clearer requirements, as is the case within the pharmaceutical industry. Maybe it's a long way to go, but if we can make requirements, then it would be possible also to verify the fulfillment of requirements and to document this. These are very, very important cornerstones, I think, in the quality assurance in this context, that we maybe the most important thing to bring along from the pharmaceutical industry side. So, thank you very much.
Okay, thank you, Lars. You was the last speaker, and now I ask all the speakers if you open your videos, and we can start for the general discussion here. And some of the comments or questions in the chat are a little bit general, some are very specific, and I don't know, do we have a real expert for all the comments? But maybe you can ask here the last comment for the chat is that digitalization and clean rooms. Do you know, Lars, how is utilizing there? Is that difference? Are they more fancy in the clean rooms?
I don't know. I think that it has been in. I should put it like this. surveillance is really important. You have surveillance of room pressures and airflow rates and so on, and that is done with the most robust systems you could find. So I think that they are not very interested in trying new Internet of Things solutions not in the pharmaceutical industry. You want to do as you always have done, because then the Food and Drug Administration and Läkemedelsverket and so on will approve to what you are doing. But yes, surveillance is really important.
So they follow the book.
Not too much sophisticated Internet of Things.
What about, if Lars continue for your side, you didn't much talk about infiltration for envelope or air tightness or this kind of thing. What do you think about for that clean rooms?
In clean rooms?
Much better.
Yeah. It's really important, and a lot of time and effort is spent on that. And you actually, I think the issue is called integrity. That the structure should have integrity, so that particles cannot be transferred from outside or from other parts of the building through cracks, through electrical installations, through any, and it, as everything else in that side, that is tested as well. On the expected dirty side, you release some tracer. Generally, it's some oil aerosol, and then you sniff for these oil particles on the clean side.
Okay, if I then rise up some things here, I think there's mentioned the air tightness in a couple of places and demand for the old buildings. What about, if I ask Peter for you, in Sweden, is there anything in OV core for the air tightness in the existing building stock? Do you have to focusing on that?
Well, the actual legislation is pretty general and open, so it says you have to make investigations into the system that you can make you can make a judgment on how the system is working. So there's no specific measurements addressed in the overkill system. But we have the standardization on measuring techniques. So it's pretty common in Sweden that you test the integrity of the ventilator and ducting, but it's not mandatory to do it.
What about how you see the situation in the new buildings? Is the air tightness challenge, or is it a problem?
Yeah, we have some earlier speakers talking about it, that we can see that the envelope tightness development have made the steering of the ventilation systems more precise, or the need for the precision of the steering system is higher now, and there's been some problems with how to measure the pressure differences and airflows and so on, so to be accurate enough to be able to steer depending on the new envelopes. And as we earlier speaker talked about, that the replacement air handling is much more vital to address. You can't, as for example in Sweden we have thumb rules about 10% leakage or 5% over volume, and those kind of thumb rules on design, and it's not accurate enough now to be able to get proper function in the systems. And now when we have DCV systems as well, the measurements and the precision of the fan handling and so on has to be good enough. So there's discussions ongoing in Sweden on those issues, but it's not in the legislation. It's the branch discussions build functional systems.
What about in Denmark? Niels or Johannes, any comment for tightness of ductwork? Is that a big issue?
Well, the overall requirements in Denmark works in that way that when you install a complete new system, then you need to fulfill the requirements. And as I remember, there's requirements for the air tightness of the ductwork. When you renovate existing ductwork, changing maybe only smaller things in it, then we don't have any requirements. It's the requirements that went into force at the time of the construction of the building. And if there wasn't air tightness requirement at that time for the ventilation system, then there won't be for the existing buildings. But we do require that the ventilation system are kept in the condition that it's built to be. So when we do it now, and it's in existing buildings in 20 years or 15 years or something, then the requirements for air tightness is still working, you can say.
Okay, I rise up one question here dealing with the car parks and garage. If I continue, Niels, for you, is there any discussion about for the design of ventilation in the car parks? Now we count electric vehicles are coming slowly, but maybe in the future is a common solution. So how we size the ventilation then?
Well, we are not very specific in Denmark on how to do the garage ventilation anyway, so I don't think it will disturb. I think, as far as I remember, there's a requirement for larger parking areas that you need to have a ventilation unit that removes the emissions from the cars and the explosive gases. But that requirement is not more specific than that. And of course, the assumptions change if you change the different cars. We're more looking into how to deal with the electrical cars parked in car parks and the risk of fire in those. But that's another discussion, I would say.
So anybody else have a comment for car situation? Peter?
The legislation in Sweden is the same. We had a lot of liters per second for different uses earlier on in our legislation, but now we said the air quality has to be good enough, depending on what action is taking place in the space. So but there's a lot of old school approach to the problem. So there's a lot of designers asking for easy liters per second to design from. So there's a discussion, but we don't have any specific liters per second.
I think there is also a question about this exhaust. I think it's maybe a local exhaust, kitchen ventilation. Is it that you're working on in Denmark at the moment? Kitchen exhaust or industrial case? Kitchen?
Well, it's not industrial cases. It's only in homes we're working on. So
you are giving new demands for ventilation airflow rates or some kind of performance testing there, or what kind of demands you are planning to put it there?
On exhaust in homes?
Mm.
Well, we worked on these requirements for quite some time, and we thought we had we thought we solved it. We had used an approach that says that you can use these odor reduction factors in these two European standards to document whether or not the exhaust hood is sufficiently efficient, and we don't agree apparently with some of the parties in the industry that this is the right way of doing it. So we're kind of like transforming the requirement now, but can't really say what it's going to be yet. It's going to come into the hearing.
What about you, Juhani? What do you think about industrial challenges now? What we should improve? Legislation. You didn't that that's not a problem in your talk.
Yeah, the product approvals and product regulation is not a problem. There is not much, but of course there are good ideas here that we have heard today. But difficult to say. Like we said, it's good to give inspiration to discussions. So that's what we have got today. I'm sure of that. But cannot yet say what it will lead to. Let's hope that we will continue working together.
I think there is also some comments for the sensors and VOC sensors and their accuracy. I think, is this the topic that Lars, you can comment on it? What VOC sensor actually measure, how good they are?
Yeah, they measure, among other things, VOCs, but they measure most probably also humidity and temperature. I saw it's becoming old now, but it was when RISE, Research Institute of Sweden, was called SP in Sweden. Many years ago, they made a test. And I think the conclusion was that many of the VOC sensors were rather temperature and humidity sensors. But of course, that field has developed. But I would say that you cannot be sure what to measure. But perhaps you could say that at least you measure something that most likely comes from the occupancy. So it could be a good occupancy sensor, but and maybe you don't need to know exactly what parameters that influence the signal. Sorry, Peter.
Yeah, I just want to add that the most, well, the front runners in Sweden on these topics, they don't use these measurements to trace a specific level. They choose to follow how a building performs towards different loads and search for outliers and uncalled for behavior to trace good or bad situations to be able to learn. When we see the big actors in Sweden, they're not very focused on the actual number. They want to look at the whole stock and see how the stock is performing.
And maybe it's a strength then to look at the signal that could depend on activities in the building in various ways. But one drawback I can imagine is that you cannot know the source strength of what you are measuring. That's actually a strength with using carbon dioxide. If you have a calibrated carbon dioxide sensor that measures with reasonable accuracy. At least I claim that I know fairly well what the CO2 generation is, and then I can estimate the air change rate or ventilation rates from such a measurement. It's a tracer gas.
I also want to add that Lars is also working with those kind of solutions, but when we're coupling the sensor data with questionnaires and actually ask people how they feel in the environment, then we get a new kind of connection that they haven't had before. That's really interesting to follow.
Absolutely.
But maybe different manufacturers' results or data is totally different. You cannot really compare any numbers, what you're saying here.
Very true. So standardization is a vital part of this. And as I said, there's ongoing projects on particular matter meters and other kind of sensors that we have to be able to know what we have been measured, or what have been measured.
I think there is also something about heat recovery here, and this kind of topic. But is that now ongoing topic for the countries? I think, Juhani, we have Finland one project with the heat recovery, I remember. Heat exchanger.
What do you mean?
Cold climate, frozen, and this kind of things.
Yes, that is true. We had a small study on what kind of requirements we should put or set on heat recovery operation, and that was done 1 or 2 years ago now. On a very practical level, the problem was that in cold and Arctic climate, the heat recovery units they freeze in the coldest time of the year, and then when they freeze, they will increase the consumption of electricity. You have to heat the incoming air with electric energy, so peak load is quite high then. And in the study, we just listed a number of parameters that the ones who buy air handling units, they could specify what they can require from these parameters. And also we fixed a certain indoor humidity level that should be used when dimensioning the heat recovery unit. So that is one study that has been made.
Do you have anything similar in Sweden? I think your climate is quite similar to what we have. Heat recovery.
I have one reflection on that one. There are many old waterborne heat recovery systems, hydronic heat recovery, not the heat wheel, not the rotary, but water coils that give really poor efficiency values. And there is a project at Chalmers University going on now about how to restore the efficiency of such systems. And I think it looks quite promising by ensuring that you have an appropriate fluid, the liquid. You should not have too much antifreeze mixed in. Then the thermal properties goes down, and you should have the right flow rate of the fluid with respect to the airflow rates, and perhaps you could achieve a lot by regulating the water, the liquid flow rate with respect to the airflow rates, which is an issue in demand controlled systems. So we have indications that you could go from a low temperature efficiency of maybe 30% or so. If you do it properly in the same system, you could reach 60 or 70 or even higher. That's interesting, I believe.
Yeah.
And then you eliminate the risk of transferring contaminated exhaust air back.
Yeah, in our study we didn't go deep into different technologies, so we just studied about heat recovery without going in the plate or rotary or run-around coils, just on a very generic level. And the reason for this is that the problems and the solutions when you go into the technology, they are very specific, and that was not possible to deep in that end of the swimming pool. And I just remembered why we started the project. The reason for starting it was that the European regulation for air handling units, they tightened, or they planned to tighten the heat recovery efficiency requirements from the existing ones, and even now we have problems. Namely, the better the heat recovery efficiency is, the easier it is to get the heat recovery unit in ice. So there must be some kind of a balance, what you gain and how often you need to melt the ice away from the unit.
There's been quite some problem with small rotating heat recovery units in dwellings where they have had problems with the steering techniques and that they didn't handle the moisture loads because there was when the peak loads arrived. So there's been some investigations on some reports on how to make them more robust with preheating or after heating and better steering equipment. So and then we have had moisture access levels of way above 7 grams and so on. So they can be pretty poor if they have faulty designs.
Okay, I think we have discussed the comments what we have in the chat, but before we close, I think I would like to thank Siru and Mervi. If you open your videos, we can say thank you for you, because without you it's impossible to make this happening. Siru and Mervi, we can see you.
No, I think we are in the back.
Back office, yes.
Back office, but
Okay.
but maybe I think it would be very good to give some last words to Hans Olof. Would you like to tell something about the cooperation and the future cooperation?
Yes, I hope to be able to convince my general director at Boverket to continue the works, and he's going to steering committee meeting next week with the Nordic countries in the Nordic ministerial councils. So and I know that they are focusing on ongoing collaborations. So as this has been going on for a year, I hope I can tell him good enough from this meeting when I'm meeting him tomorrow morning, sending some ideas with him to the steering committee. So I hope for the best as we have started planning the next year in Sweden. I think you have all done your works for next year's, have probably all started. So this has been, I think it's been a very good meeting, and I hope, as I said, it will continue, and to see more meetings. And looking at the climate forum started 3 years ago, they are having their, I think, 3rd meeting next week. So I hope for us to go the same direction as them. So thank you all participants and speakers for joining.
Okay, thank Hans Olof, and also I would like to thank for the behalf of Scanvac for this webinar, and thank you for all the speakers, and I'm quite sure that we have new events in the near future. So thank you and have a good afternoon.
Thank you.
Thank you.
Thank you. Bye bye.
Thank you.